Good morning to all. Myself, Sachin Nandgude, professor at Department of Soil and Water Conservation Engineering, Mahatma Phule Agriculture University, India. The study which we have conducted at the various locations about impact of soil and water conservation measures on the carbon sequestrations. That's what we are going to discuss today, or we're basically from the last 7 years we are conducting these studies and the three different watersheds, and we we are really with next please. Yeah, specifically as yesterday we celebrated the World Soil Day, having the very good or pertinent theme of this year of soil and water, a source of life, with a goal of raising the awareness about the importance of soil and water. So this is what also we are focusing today about the what we are doing or what we need to do in the future. Next, please. So the basically we know about the adversities about climate change, what we are facing in the last decade or two, with the long-term shifts in the various weather patterns. And the majorly, the human activities are the main drivers in accelerating this climate change. I'm talking about the human activities related to natural resources, not about industrialization or the urbanization. I'm focusing here about the fossil fuels, deforestation, overexploitation, and the unscientific land use change patterns. And all these things are accelerating, or we can say they exacerbating the next please, the issue of a climate change, or the what we can say going it's beyond the level of its control. So we need some of the strategies or which are technically possible or the economically feasible to reduce the atmospheric carbon. Perhaps the carbon sequestration is the prudent step in that direction for the to mitigate the climate change. Next, please. So here we are trying to go for a carbon sequestration, which is nothing but like transferring atmospheric carbon to a long-lived pools. There are various long-lived pools which are there in the nature. The largest one is the deep oceans. The second is the geological sequestration, which is in the form of fossil fuels, what we receive now. And the third largest is the terrestrial carbon sequestration or the terrestrial pool. So we will be focusing on the terrestrial pool, where the carbon sequestration rates we are trying to improve upon. Next, please. And in this terrestrial carbon sequestration, specifically the carbon which is sequestered through the plants and in the soil, that's what we are trying to improve upon. Or we last 7 or 8 years of study has shown this has the large, very good potential for the carbon sequestration in mitigating the climate change. Next, please. Uh, so the in the terrestrial carbon sequestration, there are two pools. One is the biotic pools in the form of the carbon which is sequestered in the vegetation, and the pedologic pool, which is almost 4 times larger than the biotic pool in the soil. Next, please. So here the what we are trying to introduce a concept of a carbon neutral watershed at a local level. What we are trying to do over here is to strike a balance between emitting carbon and the absorbing carbon. To achieve the net zero emissions, the greenhouse gas emission has to be counterbalanced by the sequestration. To achieve this target, first of all, to have understanding of the emission sources, quantity of emissions, and how to mitigate them. Next, please. So in that, what we're trying to do, first trying to identify the quantify the resources where the carbon emission occurs in the form of carbon footprint, the adaptation measure where the negative impact needs to be reduced of this carbon sequestration, and the mitigation measures where we can go for improving the carbon sequestration. So our focus in this will remain upon the carbon sequestration, improving the carbon sequestration as a mitigation step. Next, please. So as we have seen the watershed development activities for the natural resource management, or we can say the conserving a soil, reducing the soil erosion, degradations, improving the soil moisture conditions, that to everybody accepts about. But the new paradigm of a carbon sequestration through the watershed development activities, what we're trying to go upon into it. There are various conservation activities like conservation agriculture, zero tillage, cover crops, as explained by Dr. Said also before this one, the crop rotations, afforestation. I will be focusing more on the soil and water conservation measures, how they are improving the carbon sequestration rates. That the studies which were conducted, that I will try to show you. Next, please. So here the carbon sequestration rate as reported by the various sources. Here the serial number 2nd and 7, where the studies are more focused about the various conservation practices like terracing, the barriers against the slope, and the water harvesting structures, how they are improving the carbon sequestration rate in the particular regions, particularly tropical, semi-arid tropical regions of Maharashtra, where this Maharashtra state in India, where we have conducted the study. Next, please. So here in this purpose, what we have done, we had selected some of the watersheds, we estimated soil losses, we had estimated the sediment loss, which carried through the various streams. Next, please. And the water loss in the form of runoff and related carbon loss through these losses. Like this, what the carbon which we are losing, maybe through atmosphere, maybe from the watershed to the storage structures. So this is what is the basically the carbon losses related to the runoff and soil loss we are trying to get it. Next, please. And the study which has been conducted at the 3 watersheds, the first of that is the Urmodi Basin, which is of 43,000 hectare. In this watershed, this is a particularly rain shadow watershed due to the Sahyadri mountain ranges of the west coast of India. The rain shadow area is getting a less rain, but some of the areas are having a heavy rain area in this watershed, but the majority of area is typically we can see a semi-arid regions of these watersheds. Next, please. So in this, we have estimated the soil loss before conservation measures, and the soil loss after the conservation measures has been drastically reduced from 30 tons to almost 8.5 tons per hectare per annum. And majority of the 72 micro watersheds out of the this has been divided into 72 micro watersheds, and the majority of the micro watershed has changed from the very heavy or high erosion class to moderate to slight erosion classes. Next, please. And similarly, the carbon sequestration has been improved almost like 20,000 tons to 300,000 tons per micro watershed. Not it is total, it is not per hectare, but it is in each micro watersheds. Next, please. Similarly, the another study which is conducted in a very different agroclimatic zones, we can say in the Ratnagiri district, which is a coastal zone having a very rainfall, very heavy rainfall, maybe almost like 3,000 to 4,000 millimeter of a rainfall. And at the same time, it is having a different lateritic type of soil and the hilly region having undulating topography. Slope is going to the range of like 20 to 30%, 35% of a slope. These are the steep hilly slopes. And in that region, we have conducted study, particularly districts with covering the 6 watersheds. Next, please. And in that the studies, if the average annual soil loss is almost like 37 tons, has been reduced to 9 tons or more than a 9 tons per hectare per annum with the conservation measures. Next, please. So the here this is being the very important mango belt, the world famous Alfonso variety of a mango, which is having a most sought after mango variety because of its richness in proteins and like vitamins particularly. So in the mango crop, because of the conservation measures in the whole Ratnagiri district, the carbon sequestration has improved by more than 7%, or we can say almost a 10% of a carbon sequestration improvement only by the conservation measures has been observed here. Next, please. So, and based on these first 2 studies, we have started another third study in the last 6 years, we can say, which is a very specific one in one watershed, where various conservation measures for the various types of a land use patterns and for the temporal purpose, how these conservation measures behave. So this watershed is the central campus of the MPKV Agriculture University. So this whole watershed is controlled watershed. We have all the controls in this, and it is of almost 1,200 hectare of watershed, in which we have conducted a study where we have half of the watershed has been covered under the various conservation measures. Next, please. And half of the watershed is without any conservation measures. If you look into it, the conservation measures which are carried out is almost on the 550 hectare out of the 1,200 hectares. And these conservation measures are deep continuous contour trenches, compartment burning, or the nala bund, which is on the water harvesting structure, and the loose boulder structures. Next, please. And if you look to the impact of these conservation measures from the last 6 years, the 2016 is the when the conservation measures were started adopting. So it is a before adoption of a conservation measures, and the study continued up to 2022. It is typographical mistake. It is 2022. So the soil loss has been reduced from 18 tons to 9 tons, and the area under the slight erosion class and the moderate erosion class has increased in the last 6 years, and area under the severe and the very severe class has been decreased. Next, please. Similar kind of a impact you can find on the carbon loss also, which has been along with the soil loss. The carbon loss which has been measured, the if you find extremely severe and the severe class carbon loss has been reduced, but the carbon loss under the area under the carbon loss of very low and low has been increased. So this is about a carbon loss from the particularly the treated area. So how the each treatment has behaved, or the how the each treatment has improved the carbon sequestration through these various conservation measures, we are trying to focus on that. Next, please. So this is what is the ultimate result what we got from the last 6 years. We have a various land covers which were there previously. Now we have adopted various conservation, soil and water conservation measures like compartment bunding, the deep continuous contour trenches on the various land area treatments, as well as loose boulder structures, percolation tanks, and the other nala bunds are the water harvesting structures. If you look the carbon sequestration rate, it has been improved from the 190 to values in brackets are the before conservation measures. They are the values of 2016, and the values outside the bracket are the current values of the 2022. So due to conservation measures, a particularly carbon sequestration rate has been improved almost everywhere. If you look to the barren land was previously acting as a carbon emission areas, which was having a negative value of 112. So that has become a carbon sink later on once we adopt a conservation measures over there. Next, please. So what we are trying to focus over here, the carbon sequestration through various soil and water conservation measures, which has not been considered till date about as a carbon sequestration instrument for the carbon sequestration, can be a prudent ways in the future for the carbon dioxide, like atmosphere, reducing the carbon dioxide from the atmosphere. The carbon neutrality goals are there for the each nations based on their activities. So this watershed, carbon neutral watersheds at a local level can be a good solutions or the viable solution for that, and can be a new paradigm for the climate change mitigation. Most important thing is that it can be an additional benefit or the incentives to a farmers or those who are working in the watershed development in the form of carbon credits in the future. We can give economic benefits to a farmers in the form of carbon credits if this carbon sequestration has been converted into a carbon credits. That is our future activities or the future jobs, what we are looking for to convert these carbon sequestrations, particularly for the various types of watersheds in the form of what we can say is the various watershed activities, and to convert that into a carbon credits and give the benefits to a farmers particularly. Next, please. This is all. I acknowledge the support provided by our Honorable Vice Chancellor of our university, Dr. Patil, and the Padma Shri Popatrao Pawar, the Model Village Development Executive President, who has funded the last project about the getting a particular values for the various conservation measures. Next, please. So there are few publications. Next, please. On this carbon sequestration. Next, please. Next, please. Okay, thank you. Thank you very much. This is all from my side.